Welcome to applications. We're only doing one application in this video. We got bonus applications in the bonus video. 3.3D will be full of bonus stuff. All right, so we have an equation here. And so let's say that X signifies somehow the amount of labor. Maybe it's the hours worked per week amongst all of your employees. Maybe it's how much you have to pay the employees. But X signifies somehow amount of labor in your company. And Y is going to be capital, which is going to be like, think of capital as the money that we're spending on things. So maintenance of equipment, buying new equipment, all that stuff. X is people, Y is things. So when you say labor and capital, that's what we mean. So we have this curve here. It's not a function. We have a curve here. That represents all the combinations of labor and capital that will produce 3240 units. And you can see, right, as we increase X, as we have more labor, we don't need, right, Y goes down. We don't need as much pretty things. But, right, if we decrease labor, we're going to need more and more. Y is going to go up. We're going to need more and more fancy equipment or whatever. That's the relationship here. Fun fact, this curve is called a production isoquant. All right. Isoquant for iso, meaning same. Quant for quantity. So same quantity, right? These are all the pairs of labor and capital that give the same production. Okie dokie. It's also called a constant product curve. Anyway, we're looking for the slope at this point. So, you know, the slope at this point kind of is going to look like, right? The slope is going to be the slope of that line. We're going to find the slope with implicit differentiation. And again, a lot of times I really just don't like using the product rule. I'm going to move the X over. Oh my word, that is not right. I'm going to move the X over. You don't have to. We could divide both sides by 60x to the 3/4 if we wanted to. Just make our lives a little easier. The right-hand side is now 54 times x to the negative 3/4. Completely optional step. And then we ddx both sides. The derivative of the left-hand side, power rule. 1/4. Subtract an exponent. It's now negative 3/4. Multiply by the derivative of the inside, which is y prime. Derivative of the right-hand side is going to be negative 3/4. What is 3/4 of 54? 42, I think? No. I think it's 42. Why do I think it's 42? It can't be 42. Yeah, it can be 42. It is 42. It's negative 42. And subtract an exponent. Subtract an exponent, we're going to get x to the negative 7/4. Okay. So now what we're going to do over here is solve for y prime. Multiply both sides by 4 times y to the positive 3/4. Right? So we multiply by 4, we're going to get negative 168. Oh my word. Times y to the 3/4. And the bottom just has y to x to the 7/4. And again, right? Remember, a negative exponent just moves it from the numerator to the bottom, or vice versa. This is our derivative equation. So to find the slope at that point, we just plug in x and y. So at this point, right, at 8116, the slope is going to be negative 168 times 16 to the 3/4. Oh, I do not have room for this. Divided by x, which is 81, to the 7/4. We can plug that into our calculator. It looks a little messy here. All right, negative 168 times 16 raised to the 3/4 power, all divided by 81 raised to the 7/4 power. And I feel like there's an error here somewhere, but I don't remember where it is. This comes out to approximately negative 0.61. I think. A negative 0.61. which kind of makes sense. All right. So it is a negative slope. It should definitely be a negative slope. And it's about kind of 2/3. So this is kind of the rate of change. If we want to increase X, if we want to increase labor by 1 unit, we're going to have to decrease. We can afford to decrease capital by 0.61. All right. That's what we've got going on for us here. That is the slope, just right there. All right. And that is the video. We'll do more applications in the next video if you want more examples.